Okay, the step one is to find the reaction. Okay, reactions of this beam. Okay, this is L and this is W. Now what we have to do is that calculated by equilibrium equation. So what are the equilibrium equations? So what are the equilibrium equations? Tell me. They are sum of f of I horizontal is equal to 0, sum of the forces which is vertical is equal to 0, and sum of the moments is equal to 0. So in order to solve this problem, there is reaction two ends of the beam, that is A and B. So what is the reactions of this beam? So if we draw a free body diagram of this beam, this is called as the vertical A, VA, and simply when you take a moment over here, this is called MA. Now what happens is that by loading equation over here, what happens is that we can write a free body diagram equation like this. We know that sum of the horizontal forces, sum of the vertical forces, and sum of the moments are equal to 0. So vertical forces, which is over here, VA, by applying the vertical forces equation, VA, okay, this load is coming downwards, okay, this is minus W into whole length L is equal to 0. So VA is equal to W into L. This is one equation. Now what about the moment? Now if you take moment about here, the moment is going this direction. Okay, so MA. If we consider this moment as a positive, then this is going in this direction. So MA, and about this moment is going in the opposite direction. So with that is negative. Now minus W into L by 2 is equal to 0. So MA is equal to W L square by 2. This is our second equation. Now once we have done this particular part, we have found that VA is equal to W into L and MA is equal to W into L square by 2. Now after this, what we have to do is that we have to find the deflection equation further. We have to find the deflection equation further. Now how to find deflection equation? Okay, deflection equation. See, most of the students get confused over here. Okay, most of the students are get confused over here that what to take the section, how to take a section. Okay, how to take a section. Now how to take a section, I will show it over here. See, while we are taking the section over here, this is the beam. Okay, now this is the loading on the beam. This is the loading on the beam. Now we have over here W is WL, which is equal to vertical A, and also over here we have a moment that is W into L square by 2. So now how you will make a section? So by making a section, let us take a section over here. Remember that this whole length is L. Now, if you make a section over here, this part of a section is the x and this part of the section is L minus x. Okay, think that x is less than L. Now, this is the loading on the beam. So, after taking a cut section of the beam, realizing that this is x and this is the loading, and taking one more cut section over here, this is what? This is L minus x. This is the loading. Okay, and we know that from our shear forces and bending moment diagram, we take this moment over here and this moment here as a shear force downwards. Similarly, if we take over here, the moment over here is downwards and the shear force is upwards. Okay, now writing the moment equation is very simple for this body. See, this is mx, okay, and this particular load is going down, minus w into L minus of x into L minus of x is equal to 0. Okay, m of x is equal to w into L minus of x whole square by 2. This is our third equation. After this equation, we can able to solve the problem for slope and deflection. Okay, after that we can find slope and deflection. Now we know that E is equal to I into y double dash is equal to w into L minus of x whole square by 2. Now by single integration y dash become w by 2 into L minus of x whole cube by 3 plus a. Now by further we can know that E into I of y is equal to w by 3 into 4 12 24 into x minus of L minus of x power 4 plus ax plus b. This is the answer. Final equation. Let this be the equation 4. Now the slope equation is this, and we can further derive as follows. How we can further derive? Okay, how we can further derive? Slope and as follows. How we can write slope and deflection? Okay, so by let it call as 5. Slope of the equation of the beam. Now if this is the beam and this side is fixed, now the support condition tells us that y dash is equal to 0 over here at x is equal to 0. Similarly, y dash is not equal to 0 and at x is equal to L. So by taking the slope equation number 5, we can write that E into I y dash is equal to w by 2 into L minus 0 by 3 power 3 plus a. We know that slope at x is equal to 0 is 0. So 0 is equal to w into L cube by 2 into 3 is 6 plus A. Now what we can get is that A is equal to minus W L cube by 6. This is equation number 6. Now by using the equation number 4, E into I into Y is equal to W by 24 L minus X power 4 by L4 plus AX plus B. Now this is the equation. What we can do is that we know that if we take this particular beam, the slope at this, the deflection at this over here at this end is 0 at x is equal to 0. By using this boundary condition, we will get that b is equal to 0. Will not get b is equal to 0 like that. We have to 0 w by 24 L minus 0 by power 4 plus A into 0 plus B. Okay. And once we got A is equal to 0, so B we have received that W into L power 4 by 24, and that is also minus sign. Now by substituting this equation, constants, so E into I into y of x is equal to W by 6 L minus x whole cube plus minus W into L cube by 6 into x plus W L power 4 by 24, and W by 6 is equal to L minus x whole cube minus W into L cube by 6 into x WL power 4 by 24. So y is a function of 1 by EI by this is 24 cube by 6 of x 24. Now at x is equal to 0, we know that y is equal to 0. So y is equal to 1 by EI. So WL power 4 by 24 is 4. And this is minus, sorry, blunder, which is 0. Okay. Now at x is equal to L, we get 1 by EI. So this becomes 0. So all is left out is minus W L power 4 by 6 plus W L power 4 by 24. And by looking at this equation, we have to understand that this is 6. So 6 into 4 is 24. So minus 4 into WL power 4 by 24 plus WL power 4. What we end up is 3 into WL power 4 by 24. So this 2 and this 2 get cancelled. 3 6 to 24. WL power 4 by 6 is the deflection for this beam. Okay, so we have started with this beam, and actually we have started with this page 1, and this page 2, this is 3, and this is 4. Okay, let's solve one more problem. Okay. The second problem that we are going to solve over here is cantilever beam with point load W. Okay, that's right. Cantilever beam with point load. Now, for this beam, step 1 is to find reactions at 1 okay. We need to first find um, name sections as follows. Okay, this is the W. Now RA is equal to W. This is 1. Now MA is equal to W into L. Okay. from equation 3 for